Okay, so let's find the GCF of this one. We have 80 x cubed, comma, 30 yx squared. So 80x cubed, and then the other one is 30yx squared. All right, so notice how many terms do you see here? Two. And these terms, what is the coefficient of the first one? 80. And what's the coefficient of the second one? 30. So let's find the GCF of the coefficients first. So we looked at two different ways of doing that. One way was to actually list the factors and then find the one that was the largest in common. And the other way was that we used a factor tree. Okay, so the factor tree is probably the more efficient one. But the listing of factors kind of explains a little bit better what we mean by the greatest common factor. So you look at 80. Let's do the list first. So the list of factors. So let's look at 80. So if you look at 80, what are the factors of 80? Well, there's 1 and what? 80. 2 and what? 40. 4 and 20. 5 and, use your calculator if you need to, 80 divided by 5. All right, I'll do it for you. 80 divided by 5 is 16. All right. 6, 7, 8. Do we have 8? Nope. 8 and what? 10. 9, 10. We have 11, 12, 13, 14, 15. Okay, 16, 17. We have 16. 18, 19, 20. We have 21, 22, 23, 24, 25, 26, 27. So that's about it, right? I think that's it. All right, let's do 30. 30 is a little quicker to do. 1 and what? 30. 2 and what? 15. 3 and what? 10. 5 and 6. Anything else? I think that's it, right? So we have a lot of common factors here, but which one's the largest? Is it 10? Is that what y'all saying? Okay. So 10 is the largest common factor. So what's the GCF of 80 and 30? 10. All right, so we're going to need in the GCF, we know that we're going to have 10 as a coefficient. All right, let's do the same thing, though, using the factor tree to remind you about the factor tree. So let's do 80. So remember the little branches. So give me two numbers whose product is 80. 5 and 16. Okay, I'm going to use 5 and 16. You can say 2 times 40, a bunch of stuff, right? What do you remember about 5? It's prime, so I'm going to circle it. 16, I know, is 2 times 8, 4 times 4. I'm going to use 4 and 4. What do you notice about 4? I can break it down further, right? What do I write? 2 and 2, and this also is what? 2 and 2. All right, so all those are prime, so I can stop. So I know that 80 is 2 to the 4th times what? 5. All right, so let's do 30. 30, what do you want to use? 5 and 6, okay. I can circle 5. What about 6? 3 times 2 or 2 times 3, and I can circle those. So 30 is 2 times 3 times 5. Y'all agree? Okay, so what I'm going to do now is just list the factorization under each other. So remember, last class we said that if it's not a prime number, it's what kind of number? Composite, and every composite number can be written as a product of, not product of ones, product of prime numbers. So is 2 times 3 times 5, is 2, 3, and 5 prime numbers? Yeah. 2 times 2 times 2 times 2 times 5, are all those prime numbers? Yes. Okay, so 80, I know it's 2 to the 4th times 5, and 30, I know is 2 times 5 times 3. All agree? All right. So I'm going to circle the 2's here. I'm going to circle the 5's because that's what they have in common, right? Okay. So in 80, how many factors of 2's are there? 4. In 30, how many factors of 2 are there? 1. So how many do they have in common? Just 1. So I'm going to have my GCF being 1 factor of 2. Okay. Now I circled 5's because they have 5's in both composite numbers as a factor. How many factors of 5 are in this one? 1. How many factors of 5 are in this one? How many do they have in common? 1. I don't have 3 circled, so I can't use 3 because there's no factor 3 in 80. In 80. So it's 2 times 5? 10. Okay? All right, now, let's go to the variables now. So can I use 5 as part of my GCF? I'm sorry, y, excuse me. Can I use y as part of my GCF? No, because there's no y over here. Am I going to use an x as part of my GCF? Yes. All right, now how many factors of x are here? How many factors of x are here? How many do they have in common? 2. So the GCF is 10x squared. So if you look at that handout I gave you at the top where it says greatest common factor. So it says this, the GCF is an expression of the highest degree that divides each term of the polynomial. All right, so we haven't talked about the word polynomial yet. We're going to do that in a little while. The variable part, though, the variable part of the greatest common factor always contains the smallest exponent, which we kind of figured out ourselves. So what's the exponent here? What's the exponent here? What do I use? The smallest exponent, because that's what they have in common. All right. And then find the GCF. We're going to do that part. Well, step 1, when finding GCF, step 1 says find the prime factorization of all integers and integer coefficients. That's what this is. We did that, right? Okay. That's probably the better way of doing this. Listing them, you may leave one out, and it may have been the greatest one. So I would actually do the prime factorization for those. Step 2 is to list all the factors they have in common, including the variables. Step 3 is to choose the smallest power for each factor to the smallest exponent, and then you multiply them together. So it's kind of like right here. What's this exponent right here? 4. What's this exponent right here? 1. What's this exponent? 1. And so it's just saying, just multiply the one with the smallest exponent. So 2 times 5 is 10. So if you look at number 2, you have 140 in 140 m squared and 80 m squared. So 140 in, that's an n, 140 m squared and 80 m squared. All right. So let's look at the coefficients first. So let's do the factor tree for 140. Let me do that here. So 2 times 70. 2 is prime. 70, I can say 2 times what? 35. 2 is prime. And 35 is just 5 times 7. So I'm done with 140. So 140 is 2 to the second power times 5 times 7. So I wrote 140 as a product of prime numbers. And then the only other one is 80, which I think we already did, didn't we? Yeah, so 80 we did already. So that was this right here. So that's 2 to the 4th times 5. So if I list them under each other, like I did this right here, so let's see, we have 140, which is 2 squared times 5 times 7, and then 80, which is 2 to the 4th times 5. Okay. Do they have, as part of my GCF, am I going to use 7 at all? No, because 7 is not a factor of the other one. So I'm going to circle the factors of 2's here. I'm going to circle the 5. So I know that I'm going to need at least one factor of 2 and at least one factor of 5. Okay? How many factors of 2 are in 140? 2. The exponent tells you how many there are. How many factors of 2 in 80? 4. How many do they have in common? 2. Smallest exponent. So far, for 140, the GCF of 140 and 80 will be 2 squared, right? How many factors of 5 are in both of them? Just one. So I need how many? 1. And so, therefore, what's 2 squared? 4. 4 times 5 is 20. All right. So for those 3 terms, my GCF at this point will be 20, right? Okay. Now, what about my variables? Tell me something about that. You're not going to use n, okay? Because you don't see n in all of them, right? Anything else? You're not going to use any variables because there's m in every term. No. So what's the GCF of those 3 terms then? 40. So the GCF of 140 n, 140 m squared, and 80 m squared is just 20. Okay? All right. Number 3. Round 3. You have 105x, 30yx squared, and a negative 75x squared. So one of the problems on the worksheet, one of the terms was negative. Okay, no big deal. You can, if you want to, make the G, in that case, you can if you want to make the GCF a negative or a positive, does not matter. All right, so let's look at the GCF of the coefficients first. Now the variables are easy, right? You can do that real quick. So if I asked you for the GCF in terms of the variables, I'm going to leave a space here for the coefficient. What's the only variable I'm going to need and how many? Just an x, one factor. Because how many factors of here? How many are here? No, 2 here and 2 here, right? So you need 1. So I know I'm going to have an x. Am I going to need y's at all? Nope. All right, so let's go and work with the coefficients. So 105, I know is 5 times, use your calculator if you need to. 105 divided by 5 on your calculator. 21, right? 21 is
7 and 3.
3 and 7, 7 and 3. So therefore, for 105, what's the prime factorization? 3 times 5 times 7? Okay. All right, 30. 5 and 6. And then what? 3 and 2. Okay. And so I have everything circled, so I can now write the prime factorization of that. And let's put it in order, numerical order. You don't have to. 2 times 3 times 5. Okay? And then 7, even though the coefficient of x squared is negative 75, I'm just going to put 75. So 75, that'll be 5 times 15, okay? And then 15 is
5 and 3.
3 and 5, 5 and 3. And so 75 is 3 times 5 squared. Okay? So the GCF in terms of all of these coefficients, am I going to have a 2 as part of my GCF? A factor of 2? No, because 2 doesn't occur in all of them as a factor. But what occurs as a factor in all of them?
3.
3 and
5.
5. Okay, not a 7 at all. Just 3 and 5. The question is, how many factors do you need for each? Well, how many are in here? The threes. Let's talk about three. How many factors of threes are here?
One.
One. How many here?
One.
How many here?
One.
How many you need?
One.
One. So I'm going to need one factor of three. Let's talk about fives. How many factors of five are here?
One.
Here
One.
and here.
Two.
How many? Right, two. How many do I need?
One.
One. And then what variable do I need? X. So what's the answer? 15x. Okay. So that was a quick review on what we talked about last class period. Now, remember on one of the worksheets, one of the terms is negative. So if you wanted to, you could have also said negative 15x. Okay? Negative 15x. All right. So you'll see that in one of the problems we're going to do in a little while, they're going to ask you to take out a negative factor. So it's not that difficult. Okay, now let's talk about this idea now. So what we looked at was finding the GCF of two or more terms. And when factoring polynomials, so we're going to now talk about factoring polynomials. All right, factoring polynomials. We first of all need to kind of talk about what a polynomial is. A polynomial. So a polynomial, now these are examples. There is a formal definition that uses a complicated expression. But we're going to just talk about in terms of examples. So these are examples of polynomials. So 3x squared plus 5x minus 7y. Just write that down. That's an example of a polynomial. So what makes it a polynomial is the fact that it's made up of one or more terms, and these terms are called monomials. So mono meaning one. So if you look at that first term, the first term is what term? 3x squared. That's the first term. So it would be a monomial. It's a monomial that one term. You got to look at your exponent also. So notice, what's the exponent of the variable? 2. Okay, so the exponent is a whole number, then this would be considered a monomial. Okay? So remember, a whole number would be 0, 1, 2, 3, and so on. Okay, those are your whole numbers. No decimals. A whole number is not a decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. What's the second term? 5x. What's the exponent? Is that a whole number? Yes. What is the third term? Not 7y. Negative 7y. That's going to be important. Okay? Negative 7y. I mean, although you read it as subtract minus 7y, remember in a previous course, 7 minus 6 means the same thing as 7 plus a what? Negative 6. Okay? You learned that you can rewrite a subtraction as an addition problem by adding the opposite. So be careful that third term is not a 7y, say negative 7y. And what's the exponent? 1. All right. Another example would be something like 2/3 x to the 5th power minus 6x squared plus 2. And I should not have listed the same amount of terms. I don't want you to think that a polynomial only has 3 terms. Poly means many, so it can have many terms. All right, so how many terms did I just write?
4.
4. If you look at the exponent of the first term for the variable, what is it? 5. So that's a whole number. We're good so far. Now, what is the second term? Negative 6x squared. Was the exponent? 2. We're good. Now go to the last term. What's the last term? 4y. What's the exponent? 1. Now, you see this monomial right here? There's no variable in it, right? Okay, that's called a constant. That's called a constant. So your constants are just numbers. So I use the word constant. In that first polynomial I wrote, do you see a constant? No. There's no constant. Now 2/3 would be called what part of this monomial? Coefficient. What's the coefficient of the second term? Negative 6. Okay. All right. What's your constant again? 2. All right. Now what we're going to do is start factoring these polynomials. So the first step in factoring is to always factor out the GCF. Step 1, factor out the GCF. Okay? So step 1 of factoring. Step 1 of factoring polynomials is to factor out the GCF. Okay? All right, so let's look at this example. Okay, so we're going to factor each polynomial. Now 1, we have 8x minus 12. 8x minus 12. So we have this polynomial. It has how many terms? 2. Okay, so you want to look at those 2 terms and you want to ask yourself, what is the greatest common factor of those 2 terms?
4.
Okay, anybody think anything else? First of all, is my greatest common factor going to contain a variable? All right, based on what we talked about last week and a while ago, does every term contain the variable x? No, so I'm not going to use x at all as part of my GCF. So the first question I'm going to ask you is, what's the GCF of your terms? What are they? Or what is it? 4. Okay, so with most of these, you can visually look at it and determine what it is. You don't have to do all that work we did previously. Okay, so that's a GCF, right? Okay. So when the first step in factoring is to find the GCF. Now, listen carefully to this. I'm going to write it out first, and then you'll see that it does make sense. So remember when we talked about factoring beginning of last class period? For example, I think I wrote down 8. I said 8 is 4 times 2, right?
Yes.
And I said that 4 would be considered a factor of 8, which it is. What else would be considered a factor of 8 based on what I just wrote? 2. All right, so, and then we talked about the fact that when you think of factoring, you think of what operation? Multiplication. So when you factor a polynomial, you want to write it as a product. You want to write as a product. And the product, for us right now, the product would look like this. It will be the GCF times another polynomial. The GCF times another polynomial. So in this case, what is the GCF? 4. Okay, now you got to remember this idea. Quick review. Last semester, you were asked to multiply this. 3 times 2x minus 7, let's say. What did that mean to multiply that? Distributive property. That's what that meant. So you'd say 3 times 2x is 6x, and then 3 times a negative 7 is a negative 21. That's what that meant. So when we factor, you're going to use these ideas to determine if what you have is written correctly. You can use the distributive property. So do y'all agree that when I factor out my GCF, which is what number?
4.
4, and I put that in parentheses, I'm going to ask myself, 4 times what is 8x? 2x. 4 times what's a negative 12? Negative 3, and that kind of is this distributive property that you're using. This is your answer. So you factored 8x minus 12. How do you factor 8x minus 12? You wrote as a product of factors, didn't you? Yeah. The first factor is your GCF, and then the second factor, what's the second factor? No. Just tell me what's that first factor you see? Your GCF, which is 4. What's that second factor? 2x minus 3. When I read this, I read it as 4 times what? 2x minus 3. Kind of like I did here. 4 times what? 2. 4 is a factor. What else is a factor? 2. 4 is a factor. What else is a factor? 2x minus 3. All right. So when we factor the polynomials again later on, it has 2 binomials. Those binomials are considered factors because it's written as a product. So you look at this. This says, read it out. It says 4 times 2x minus 3. So those arrows are pointing to your factors. What's that first factor? 4. What's that second factor? 2x minus 3. And if I multiply them, if I were to do what I learned last semester, I would get that polynomial back. Okay? All right. So always use what you've learned in the past to help you with what you need to know now. Number 2. Suppose I had x to the 7th plus 2x to the 9th. Now before we do that, then let's remind ourselves about something you learned last semester. So this is review number 1. This is review number 2. If I had x to the 8th times x to the 3rd power, what's that? The same as x to the 11th. One of the things you learned last semester when you multiply variables was that if the bases are the same, you add the exponents. That was called the product rule. Product rule. So remember the product rule for exponents. It's called the product rule for exponents. If I have x to the a, that's an a, times x to the b, then the answer is just x to the, and then you add the exponents, a plus b. All right, so you multiply like bases. That's a phrase you learned. When you multiply like bases, and notice what's this base that I'm pointing to right here? X. What's this base here? X. They're like bases. I'm multiplying like bases. You do what to those exponents? Add them up. Okay? So this would be x to what power? The 11th. All right, that's going to help us with this one also. All right, now, how many terms are in that polynomial for number 2? 2. You have enough knowledge to tell me what the GCF is.
1. X. It's X. No, it's actually X to the 7th.
X to the 7th. How quickly you forgot. How many factors of x are in this term?
7.
How many factors of x are in this term? 9. How many do they have in common? 7. Y'all forget pretty quickly. And what's this coefficient right here? What's this coefficient right here? What's your GCF? 1. So altogether, what's your GCF?
X to the 7th.
X to the 7. So GCF is x to the 7. X to the 7. Now, I want to factor this, though, right? Factoring means to write as a what? Product. Product. So I'm going to put the GCF first. What's my GCF? X to the 7th. And I'm going to say times, and I need something inside those parentheses. Now, keep in mind that how many terms are in the original polynomial? You better have 2 terms inside the parentheses. X to the 7th times what is x to the 7th? 1. So I need to put a 1 there. X to the 7th times 1 is x to the 7th. Kind of makes sense. Use the distributive property in your mind. Plus, x to the 7th times what is 2x to the 7th? 2x squared. Kind of makes sense because if you think about it, that's x to the 7th times 2x squared. So this right here is going to be a 1, right? What's 1 times 2? 2. What's x to the 7 times x squared? Which is what I wanted. So there's your answer. Okay? So always use to check, always in your mind, use a distributive property. If you thought of anything else here, think about why it's not correct. If you multiply it out, you'll see that you would never get 2x to the 9th if you use something else. Okay, let's look at number 3. I have 4x minus 6y minus 8. 4x minus 6y minus 8. How many terms are there? 3. Now, I want you to write down real quickly, don't say it out loud, and then check your neighbor what you think the GCF is. Real quick. Ah. All right, is your neighbor's correct? You don't think yours is correct? What is a GCF? 2. No variable, right? It's just 2. So if you look at 4, 6, although it's negative 6, just think 4, 6, and 8. What's the greatest common factor for 6 and 8? 2. So there's my GCF. It's 2. So then I want to factor this, though, right? Now remember, make sure you're reading directions carefully. The directions does not say find the GCF. The direction says to do what? Factor. Factoring, the first step in factoring is to find the GCF. And so you're going to write this as 2 times, because remember you're factoring, so you got to write a product, the GCF times whatever needs to go inside this parentheses. How many terms were there originally?
3.
How many terms had you better have inside the parentheses? 3. 2, use the distributive property. 2 times what is 4x? 2x. 2 times what's a negative 6y? Negative 3y. And then 2 times what's a negative 8? There's your answer. You factored. You wrote it as a product of factors using the GCF. You have to use the GCF. Okay, number 4. All right, number 4, let's suppose we had this. You had 15x cubed plus 9x squared. 15x cubed plus 9x squared. All right, now you need to get quicker at this. You need to get better at this. What do you think the GCF is? 3. 3x squared. Very good. 3x squared. So if you look at 15 and 9, what's the greatest common factor of 15 and 9? 3. I have 3 factors of x here, 2 factors of x here. How many factors of x do I need? 2. All right, so the GCF is 3x squared. Now, that's not the answer to the problem. You just found the GCF. Now, you want to factor. Well, one of your factors better be the GCF. So I'm going to say equal 3x squared times, and I got to put something in parentheses. And that's where the distributive property from last semester comes into play. 3x squared times what is 15x cubed? 5 what? Very good, 5x. Because what's x squared times x? X cubed. All right. Plus 3x squared times what's 9x squared? 3 only, not an x. Did anyone think about putting an x there? Okay, well, let's check it. 3x squared times 3x. Let's say you did put a 3x. What's 3 times 3? What's x squared times x? Is that what you wanted? No. So always check. Always check to make sure what you wrote makes sense. All right, so it was not a 3x that had to be there, it was just a 3. Okay, all right, so there's your answer to that one. Number 5. So in 5, you have 12x squared y minus 42xy cubed plus 48x cubed y. So 12x squared y minus 42xy cubed plus 48x cubed y. So what I would have done there, if you look at those three terms, the coefficients are 12, 40, negative 42, and 48. I would have looked at the smallest of those, and what's the smallest of those? 12, right? I would look at the smallest of those, and I would look at the I would look at the factors of them. What's the largest factor of 12 besides 12? 6. Will 6 go into 42? Yes. Will 6 go into 48? Yes. You found the GCF. What's the GCF of those numbers? 6. Okay? Will 12 go? Now, you might say, well, why couldn't I use 12? Well, 12 goes into 48, I agree, right? But does 12 go into 42 evenly? No, that's why we couldn't use 12. Okay? So the next one below that was which factor? 6. All right, so that's the way, just think strategically. Look at the smallest of those and then look at the larger factors and see if we'll go into the others. And you have access to a calculator. Use your calculator. All right, so far my GCF is 6. All right, now let's talk about the variables. One factor of x I need and one factor of y. Okay, so very good. The GCF is 6xy. So then that means I'm going to rewrite this as 6xy times
2x.
All right, so let's think about this. 6xy times what is 12x squared y? What do you think? Anybody think something different? Let me know now if you did. So all of you think it's 2x, okay? You know you're not going to need a y, right? If you put a y, you know, because how many factors of y do you see here? 1. And how many are you taking out? 1. So you better not have any left, right? So it's just 2x minus 6xy times what's 42xy cubed? 6 times what's 42? 7. How many factors of x do you see here? I'm already taking how many out? 1. All right, now y times what is y cubed? Y to the second, good. Plus 6 times what's 48? 8. X times what's x cubed? X squared. Do I need a y? No, because if you put a y there, what's y times y? Y squared, but I didn't have a y squared, I had a what? A y. Okay, so there's your answer. Okay, number 6. All right, suppose in number 6 I had 13a cubed b squared plus 39a squared b minus 26 ab to the 4th. All right, so 13a cubed b squared plus 39a squared b minus 26ab to the 4th. What are the coefficients? 13, 39, and a negative 26. Look at the smaller coefficient first. What's the smallest coefficient? 13. What's the largest factor of 13? 13. Will 13 go into the other coefficients? Yes.
No, all of them.
All of them, right? So what's the GCF of the coefficients? 13. Be strategic with this. Now let's talk about the factors of A's. Am I going to need any? Yes, just one. Because how many were here? 3. How many were here? How many were here? How many do you have in common? 1. How many factors of B? Just 1. So you found your GCF, and now you're just going to rewrite this as the GCF times a polynomial. All right, well, 13AB times what is 13A cubed B squared? All right, so you said 1. Just I would not write the 1. I would just leave it off because it's understood to be a 1. But it'll be A to what power? Second, and then how many B's? Just 1. All right, if you put anything else, always multiply to make sure that you see why yours would not work. A times A squared is what? A cubed, which is what I needed. B times B is B squared. Okay, good. Plus 13 times what's 39? 3. Now what else do I need? Just an A, right? Okay, no B. Because already, how many factors did I have here? How many do you see here? Just 1. And then minus 2B to the third. That's it. All right. Again, always check your work. Use the distributive property. Okay. All right. Now, the number 7. Before we go on, I'm going to put a just kind of do this for right now. Kind of separate what we did with what number 7 looks like. I'm going to write number 7 down. And the way it's written, go ahead and write it like this. The way it's written is going to be important in a little while when we talk about grouping. So don't let this confuse you. So if I cover up this part here, you read this as how many factors? 2. X times what? X plus 5. Okay. But that's a subtraction sign right here, right? So you got to think as that being separate. What are the factors of this product? Negative 2 and X plus 5. All right. So it's kind of like the subtraction symbol kind of separate this thing you're looking at into 2 parts. What do those 2 parts have in common? What factor do they have in common? X plus 5. And listen carefully to this. So if you look at those 2 things, what's the GCF? X plus 5. The GCF is X plus 5. Okay? Now, listen carefully. It's going to be important in a little while the way this thing looks. You're going to see it again. So I'm going to rewrite this polynomial. And it looks different from the others. I agree with that. It does not look anything like these. It looks totally different. But remember, when factoring a polynomial, this is still a polynomial though, because I could distribute and it'll look like these. When finding the GCF and factoring this, you're going to write the GCF first. What's the GCF? In parentheses. That's important. Okay? So x plus 5, you're going to factor out the x plus 5. All right, and then it'll be times whatever's left, right? Just like we did. GCF times whatever is left. Now, there's a reason why we need parentheses for the x plus 5. X plus 5 times what is this that I'm underlining? Yeah, it's just x. Y'all agree that x plus 5 times x is this right here? Okay, just kind of look at it. You see it. Look at it again. You see it. Minus x plus 5 times what's this? What am I missing? Negative 2. So minus 2. So there's your answer. So number 7, I factored as x plus 5 because the x plus 5 was the GCF, right? You factor it out. You put that in front. and then you ask yourself, well, I need to multiply the GCF times some polynomial. So x plus 5, I factor this out, you're left with what? X. So when I multiply it, I get this back. I'm factoring out the x plus 5, you're left with what factor here? Negative 2. That's what you see here. Kind of makes sense because x plus 5 times the negative 2 is this, right? Okay. Now, notice, see this factor right here? It was in parentheses. Keep it in parentheses. Because if you did not, if you did this, if you wrote it like this, mathematically it means this, that the only number that you're distributing is the 5. And that's not what this is. Okay? So you got to put that in parentheses. Let's look at another one. You tend to get better at this when you do a few more. Let's look at this one. And you tell me what you think the GCF is. It's going to look just like this one. Y times x squared minus 3 plus 4 times x squared minus 3. So if I look at that polynomial and see that plus, that addition symbol kind of separates those two. So I look at these two factors and then look at these two factors. What factors did these two things have in common? So that's my GCF. So your GCF is x squared minus 3. But when I factor it though, I need that GCF in parentheses. So it'll be in parentheses x squared minus 3 times a polynomial. Y plus 4. That's it. Y plus 4. So it kind of makes sense because look, I'm underlining my GCF. Y'all agree that was my GCF right here? And then I'm going to distribute x squared minus 3 times y. That's this, right? Distribute x squared minus 3 times 4. That's this. Y'all agree? So there's your answer. You factor. Remember, factoring means to write as a what? Product. And I did. X squared minus 3 is my first factor. What's my second factor? Y plus 4. Okay. Number 9. You have x times x minus 7 plus x minus 7. So x times x minus 7 plus x minus 7. Okay, so it's kind of like 7 and 8. Look at it in terms of 7 and 8. See this plus symbol? Two things. Think of it as two things. Look at the first one. What are my factors of the first one? X, and what's the other? X minus 7. Look at the other one. Now, be a little bit careful with this one. You can see that one of the factors is what? X minus 7. What's the other one? 1. Good. If there's no number there, it's understood to be a 1. That's going to be important. That's a 1. Over here, what was it? Negative 2. Okay? So what's the GCF? X minus 7. So that's not the difficult part. So I'm going to say x minus 7 times a polynomial. Use distributive property. X minus 7 times what is this? X. Plus x minus 7 times what is x minus 7? Don't say 0 because x minus 7 times 0 is what? 0. That's not what that was. X, very good. X minus 7 times 1 is itself. So you need a 1 there. And that's why I said think of this as what coefficient? 1. Okay? All right. Now, 7, 8, and 9 can be important in a little while. So keep that in mind when we come back to it. Okay, look at 10. Now I'm going to write down 10 because you're going to see 10 as in my math lab, and also I do have one in the worksheet. So look at 10. 1/3 x to the 7th plus 4/3 x to the 5th minus 7/3 x to the 9th. Okay, you have fractions. Fractions will throw people off. Okay, write that down. How many terms do you see? 3. See 3 terms. let's talk about the GCF in terms of the variables. The variable you can get right away. The GCF is going to have x to what power? X to the what? Fifth. Good. All right. Now let's go about the coefficients. See, the coefficients are fractions, right? So you have a third, you have 4/3, and you have 7/3. Okay? Notice the denominators in all of those are the same. So that means I could, in terms of the denominator, I can factor out a what? No. In terms of the denominators, what did it have in common? 3. So I can factor out a 3. Okay? Look at the numerators. 1, 4, and -7. What's the GCF of 1, 4, and -7? 1. So listen carefully. The GCF is going to be, what's the GCF of the numerator? What's the GCF of the denominators? 3. So I'm going to factor out a 1/3. Okay? And then next to the what? Fifth. So on a worksheet, there is a problem like this in the worksheet. The denominators will be the same. All right. So 1, 4, and 7. What's the GCF of the numerator? What's the GCF of the numerator? 1. That's where you see this 1 from. 3, 3, and 3. What's the GCF of 3, 3, and 3? 3. That's where you see the 3 from. Okay? All right. Don't make it difficult. And then all of you knew that it was x to the 5th. All right. Listen carefully. So what's my GCF? X to the 5th times polynomial. Okay. Now we're going to do that distributive property again. 1/3. Now the first one's easy. 1/3 times x to the 5th times what is 1/3 x to the 7th? X squared. That's it. Just x squared. All right. So all of you should have gotten x squared. All right. Now some of you are going to not get the other one because you're still having issues with multiplying fractions. I'm going to write this out right here. This is what I'm saying. 1/3 times what is 4/3? What do y'all think? Okay, some people said 4. Anything else? Y'all agree it's 4? Because if you put a 4 there, you can write 4 as 4/1, right? It's 1/3 times 4, 4/3? Yeah. So I'm going to ask you this now. 1/3 x to the 5th times what is 4/3 x to the 5th? 4 only. Very good. Because you don't need any x's. Because how many factors of x were here? How many are you factoring out? 5. Based on this discussion right here, what do you think is going to go here? Minus what? 7. Good. X to the 4th. And there's your answer. All right, let's do one more with a fraction. Number 11. Suppose I had 3/5 x to the 4th minus 2/5 x squared plus 3/5 x to the 5th. In terms of the fractions, what could you use as a GCF? No, okay, I agree that I'm going to need x squared, but what will be the coefficient of x squared? 3/5? 1/5. 3 does not go into 2 evenly. So if you look at 3, -2, and 3, what's the GCF of 3, -2, and 3? 1. And then 5, 5, and 5, what's the GCF of 5, 5, and 5? 5. So the GCF would be 1/5 x squared. And now, hopefully, more of you should be able to get the answer now. So it'll be 1/5 x squared times what? What's going to be my first term?
3x squared.
Very good, 3x squared. Because 1/5 times 3 is what? 3/5. X squared times x squared is x to the 4th. Minus 2, that's it, right? Okay, plus 3x cubed. Okay. All right. Okay. All right. Now, that first part that we just did was factoring these polynomials by first finding the GCF and then writing the answer as a product, the GCF times the polynomial. That will give us the original back. Okay? That will give us the original back. All right. Now, we're not done. I'm gonna give you the worksheets on those first, but what I want to do